To implement rate limiting, we will use Google Guava library. Google Guava only allow limit to certain number of API hits per second. This is very basic rate limiting, but for example already enough. In real life, you might want to limit to more flexible time units, not only per second rate. To do this, no easy direct way in Java. You can use API management, which gives you out-of-the-box feature for this. First, add dependency to Guava on build.gradle. Then, create file rate limit filter on package api.filter. This time, we will not annotate this class as component. We will see a sample how to manage one filter for different endpoints with different configuration each. Extends once per request filters. And create skeleton for unimplemented methods. Inside, we need rate limiter class from Guava. Create a public constructor that takes one double parameter. This double parameter is the transaction per second, which is number of hit allowed within 1 second. Create rate limiter instance based on TPS value. In the filter, we need to try acquire rate limit. If this returns true, means we still within limit and request can be processed. Otherwise, this means the rate limit already exceeded, so we must reject the request. Proper HTTP status code for this case is 429 too many requests. Optionally, we can set retry after HTTP response header. This header indicates when should the client retry to hit API again. However, don't expect that any client or even web browser will automatically retry after indicated time. This is more like telling the client when you should retry instead of you must retry after. Now, let's see example how to write Spring Web Filter to multiple configuration. This is not mandatory though. You can use global filter. Create file rate limit filter config.java. Under package api.filter.config. Annotate this class as configuration. The first filter pin we will configure is rate limit for blue endpoint. Create a filter registration pin for rate limit filter. To register, we need to create the filter and assign it to filter registration pin. Also, give it a name. In this sample, we will create rate limit filter which accepts only 3 transactions per second to URL blue. Next, rate limiter for red. We can copy paste from the blue filter registration pin and adjust it as required. This time, we will limit only 2 transactions per second for red. We also need to set the name different from blue filter. Now, let's see how the protection works. I will show my CPU utilization graphic. Try to run only the blue endpoint using Postman runner. We will run it 100 times. Now, you see that there are many requests rejected with status code 429. You might also wonder, if you see the first iteration, there were 4 rows that return status 200 while we only allow 3 transactions per second. In my experience, this can be happen since the process to check rate limit itself will take time. So the fourth hit will still be low since rate limit is not updated yet. Still, it is a lot better having 1 or 2 requests too many rather than 90 requests too many, which will burden the server. If we check the CPU utilization, there will be not much different. CPU still have certain spike. Okay, let's try it again. But now, let's open JMeter and test the rate endpoint and how the CPU works. Remember, previously the CPU is at 100% with no sign of this percentage going down. Now, run the JMeter again and wait a while. Now, when you see the report, it has many errors, which means status code is not 200. If we drill down the report, the response shows status code 429 since we put rate limit. The good side is when we check the CPU graphic, which now shows that CPU utilization not in constant 100%, although the algorithm in RAT itself still purposely hit high CPU.